So far we have seen the basics of learning, what it is, and some examples. Here we are going to discuss learning techniques, what are the various ways that we learn. Very simple, that we are going to discuss 3-4 of them. One very simple is rote learning. The other one is called deductive learning. Third one is inductive learning, and the fourth is learning by taking advice. The word rote learning, in local language, it's called ratta. Okay, what exactly is it? In rote learning, there is no prior knowledge. We cram things. Okay, so when a computer stores a piece of data, it is performing in an elementary form of learning. Okay, that is this act of storage presumably allows the program to perform better in future. Okay, so there's no kind of experience involved. It's just taking in things. As I said, rote learning is learning by heart. That's what it means. So examples of correct behavior in this case are stored, and when a new situation arises, it is matched with the learnt examples. Okay, so you have a set of correct behavior that you've stored in your mind, in the computers, and when a new situation arises, that situation is matched with the learnt examples, and that's how you correlate the two. So the values are stored so that they are not recomputed again later on. One of the easiest or the earliest game playing programs is the checkers program. Okay, this program learned to play checkers well enough to beat its creators, the designers. You can see that on the screen. We're not going to discuss how it works, but just to give you an idea what it is. So moving on from rote learning, which is kind of static data that is induced into us. Okay, we learn without experience, without thinking, and that is what happens in the database or the knowledge base. The second type is deductive learning. Now remember, we've discussed reasoning mechanisms. So like deductive reasoning, there's something called deductive learning. It works on existing facts and knowledge and deduces, infers, okay, comes up with new knowledge from old or existing knowledge. So let's see an example. Let's assume that you are given something A equals B and B equals C. Then very simply, because if we are so used to it, we can deduce, we can deduct, we can infer with a lot of confidence that given these two, C equals A or A equals C. Okay, this is very straightforward. Now one can argue that deductive learning does not generate new knowledge at all, okay, which we presume it does, but it's not generating new knowledge. All it is doing is it's simply memorizing the logical consequences of what is already known. Okay, so you know that A equals B and B equals C, so this is known, and then you can actually remember that these are dependent on each other and you infer new information, so to speak. However, it also implies that virtually all mathematical research would not be classified as learning new things. They're already there. All you're doing is you are trying to connect them together. That's what we call as learning new things. So I better be careful with the mathematical community here. This is of course new knowledge. Now regardless of whether this is termed as new knowledge or not, it certainly makes sense. The reasoning system becomes more efficient. Okay, so you know how to move between that information and conclude the result. So that's deductive learning, and as I said, this is related, which is similar to deductive reasoning as well. And likewise, we've seen inductive reasoning, we have inductive learning. Inductive learning takes examples and generalizes. rather than starting with existing knowledge in general. So it takes a few examples and then it tries to generalize, and it works sometimes, sometimes it doesn't. For instance, having seen many cats, all of which have tails, one might conclude that all cats have tails. Makes sense. But there could be example that this may not be true in other situations. For instance, you ask a few kids, do you find your homework easy? Now, let's say they say no. So, having asked, let's say 5 or 10 kids, they say the homework is not easy. Can you generalize by saying homework is not easy? You've got a small sample and you're trying to generalize. Likewise, if they say it's difficult, it's not difficult, can you generalize the other way around? So, gives you an idea what we mean, but the conclusion cannot always be exactly correct, as in the case of deductive learning. So, in general, some people say this is an unsound step of reasoning. However, it would be impossible to function without using induction or generalization to some extent. In any case, it can be improved by increasing the sample data, as I said. So, if you ask 1000 students, various colleges, universities, schools about the homework, you will be able to, generalize much better. In any case, in many areas, this is an explicit assumption. There is scope of error in inductive reasoning, as I said, but still is a useful technique and has been used for several successful systems. One major subclass of inductive learning is concept learning. This takes examples of concepts and tries to build a general description of the concept. Very often the examples are described using attribute value pairs, attribute, characteristics and value pairs. We try to come up an example for you. Look at the table. So, you've got several columns. The column says herring, cat, dog, cod and whale. And on the other side, the rows we have swimming has fins. Remember, those fins are like small little things on which the fish, they move around. Their wings, so to speak, has lungs and is a fish. Now, if you look at this entire diagram, you may be able to infer some generalizations. For instance, there are many ways of generalization, of course, but one is to differentiate between fish and non-fish. And the simplest description possibly is one of them is that a fish is something that does not have lungs. Now, apparently there is no other suitable attribute that would serve to differentiate the fish. The point is, given a small subset of characteristics, we can generalize a few things. However, that generalization may not always be true. The two most common reasoning algorithms used for this are called Virgin spaces and ID3, which is iterative dichotomizer. Just a reference, I'm not going to discuss it. That's out of scope for this. Okay, now learning by taking advice. So, you have rote learning, you have deductive learning, you have inductive learning, and then finally you have learning by taking advice. Easiest and simplest way of learning. Okay. So, for instance, a programmer writes a program to give it some instructions to the computer to perform a certain task. And once it is learned, that is, it has been programmed correctly, the system will be able to do new things. And of course, you can use several sources for taking advice in general, okay, like humans, internet. However, you need to be very clear on the source of the knowledge that you're taking in. This type of knowledge has a more necessity of inference than rote learning. As the stored knowledge in the knowledge base gets transformed into an operational form, the reliability of the knowledge source, as I said, becomes important. We need to be very careful on what we are using as our source. So, these are the few examples of types of learning. I hope you've enjoyed it. We'll see you next time. Thank you very much.